Just sort of to reiterate what you would have seen in the reading, um, a system of linear equations in two variables, or a linear system, is composed of a pair of lines in the form ax plus by equals c, or y equals mx plus b, when there are two lines on a given graph. The point at which they intersect would be a solution point to a system of linear equations. These solutions can come in singles if the two lines intersect. They can be at all points if the lines are overlapping or the two representations of the same line, or there can be no solutions where the points do not overlap. I'll show each of these in a few moments. The coordinate plane, the ordered pair indicates a point of intersection. Well, we're going to be looking at linear intersections. These can also be found using similar techniques for more complicated systems, such as linear and quadratic, pairs of quadratic, or any other system of equations. We can graph both lines and see where the two lines cross. This is generally a crude way of approaching things. It can be accurate if you're careful, but it can be difficult to have that accuracy. You can use digital graphing tools to help you with this as well. One of the two algebraic ways to do this is using a method called substitution, where if you start out with two equations with two unknowns, you solve one of the equations for one of the variables, either the x or the y, in either equation 1 or equation 2. If one of the equations is already in a single variable on one side, everything else in the other form, then that's done our work for us in this step. Since you're able to treat the two sides of an equation as equal, well, not just treat them, they are equal. So y and mx plus b represent the same thing in the case of a line. We can replace the single variable with the expression that it equals in one equation into the other equation. This will result in an equation with only a single variable. We can then solve this equation containing one variable for that variable, back substitute the value found in step 3 into one of the original equations, and simplify that value and find the value of the remaining variable. Then we want to check the proposed solution in the given equations. So let me give a couple examples here. So we have four lines. A is 2x plus 3y equals 6. B is y equals negative 2/3 x plus 6. C is 6x minus 2y equals 10. And D equals 3y plus 2x equals 18. Line A is in red. B is in green. C is in brown. And D is in purple. lines A and C intersect at this point a little less or a little bit less than 2 for our x and a little bit less than 1 for our y. B and C intersect cleanly at the point 3, 4. And lines A and B are parallel. They're separated by 1, 2, 3, 4 here, 4 here, 4 here, 4 here. So you can see that they're parallel at all points. B and D are the same line. They're collinear. So if we try to solve for the point where A and B cross, as we just saw in the graph, we're going to find that they don't. But we have B is already in the form y equals negative 2/3 x plus 6. We substitute this in for the y in A. So I have 2x plus 3 times negative 2/3 x plus 6 equals 6. 2x minus 2x plus 18 equals 6. 18 equals 6 is a false statement, and there's no x's. Therefore, these are parallel lines. A and C. 2x plus 3y equals 6. 6x minus 2y equals 10. We solve our first equation for y, first by subtracting 2x, then dividing through by 3. Then we substitute in for the y in our second equation. 6x minus 2 times negative 2/3 x plus 2 equals 10. Carefully distributing the negative 2 through, we have 6x plus 4/3 x minus 4 equals 10. We need to get 18/3 to be similar to our 4/3. So get 22/3 equals 14. Multiply by both sides by 3, divide both sides by 22, gives us 42 over 22, or 21/11, which is just a hair under 2. We can then place our 21/11 into our equation here. So y equals negative 2/3 times 21/11 over 2 plus 2. We get negative 42/33 plus, we need to convert 2 into 33, get 66/33. Add these together, and we have 24/33, or 8/11. We could also simplify here, get 14/11 plus 22/11 is 8/11. So our ordered pair point is x equals 21/11, y equals 8/11. 21/11, 8/11 is right about where the graph would suggest we would cross. That would be impossible to read from this graph. Okay. B and C, we have y equals negative 2/3 x plus 6, and 6x minus 2y equals 10. So we can substitute this y in for our y. So we get 4/3 x minus 12 plus 6x equals 10. 22 x equals 22. Multiply both sides by 3, divide both sides by 22, we get x equals 3. We substitute the 3 in for the x, negative 2/3 times 3 plus 6. So negative 2 plus 6 is 4. So we get the point 34 is confirmed for us, as we should have been able to read from the graph. We need to be careful trying to read these from the graph, though, because points can look to be in a certain place, even when they're not. B and D. If we solve B for y, we have 3y equals negative 2x plus 18. Divide through by 3, we get y equals negative 2/3 x plus 6, which reads the same as B. So we will look more at solving systems of linear equations in another video, which will be airing shortly.